We talk a lot about how amazing cloud tech is, right? I mean, all that power, all that flexibility.
Yeah.
But sometimes all that complexity, well, it can kind of open the door to, some security risks that nobody really saw coming.
Right.
And that's what we're diving deep into today.
Yeah.
This is huge. A significant discovery from the Wiz Research team. They're calling it IngressNightmare.
Catchy name.
It is, right?
Yeah.
And it affects something that's like a core building block in a ton of cloud setups, the Ingress NGINX Controller for Kubernetes.
Exactly. And this isn't like a little whoopsie in the code. Wiz Research, they found multiple unauthenticated remote code execution vulnerabilities.
Ooh, that sounds serious.
It is. We're talking a CVSS score of 9.8 here, about as critical as you can get in the security world.
Okay, so let's break this IngressNightmare thing down for everyone listening. Okay, what is it and why should you care?
Sure.
So, as the expert speaker just said, the main problem here is unauthenticated remote code execution, or RCE for short, and a CVSS score of 9.8. That's like flashing red lights, right?
Definitely. We're talking about a situation where an attacker could completely take over your entire Kubernetes cluster, and they could get access to every single secret you've got stored in there.
Every single secret. That's scary. I mean, think about it. All your sensitive information, everything, just wide open.
It is a major concern.
Okay, so before we get too deep into the technical stuff, can we just back up a sec? What exactly is this Ingress NGINX Controller thing anyway? Why should anyone listening even worry about it?
Well, you could think of it like the bouncer at a club.
Okay, I like that.
Yeah. It decides who gets in and who doesn't. So this Ingress NGINX controller for Kubernetes, it's super common, and it acts as this gatekeeper. It controls what external traffic can actually reach your Kubernetes applications. Even the official Kubernetes documentation, it uses this as like the prime example of an Ingress controller.
Right.
And it's built on the, really well-known NGINX reverse proxy. So in theory, it's got a solid base.
You said it's popular.
Really popular. Like Wiz Research, they estimate that over 40% of Kubernetes clusters that are open to the internet, they're running this. That's a ton of systems. They actually found thousands of clusters that are exposed, and some of them belong to some big name companies too. So yeah, the potential for damage here is pretty widespread.
Okay, so this thing's important. It's everywhere, and it's gave them serious security holes.
Right.
And Wiz Research really did some great work uncovering this. So let's get down to brass tacks, right?
Right.
What exactly are these vulnerabilities? How do they work?
Well, the main attack vector here, it all comes down to the Ingress NGINX admission controller. Now, this admission controller, think of it like a security checkpoint.
Gotcha.
It checks incoming requests, make sure they're legit before they can get into your cluster. But the thing is, this component, it's supposed to protect ingress traffic, but it wasn't properly secured itself.
So this security checkpoint, it's not checking IDs, no credentials.
No. Which, when you think about it, it's kind of surprising. Makes you wonder about the assumptions we make, right? About what's secure inside our own cloud environments.
Yeah.
So when an Ingress object comes in, and basically that defines how external traffic gets routed to this controller, it creates a whole NGINX configuration based on that. And then it uses the NGINX program itself to double check that that config is valid. And that whole validation process, that's where these vulnerabilities are. At least that's what Wiz Research found.
So the attackers, they're messing with the validation part.
Exactly.
This is where it gets really interesting. How do they do that?
So Wiz Research, they found out that it's possible to inject your own custom NGINX configuration right into this validation process. They can send a specially crafted Ingress object straight to this unguarded admission controller and slip in their own NGINX commands. It's like sneaking something past the bouncer, right?
Right.
And then when the system runs this command called nginx-t, which is just meant to test the config, boom, the injected code gets executed.
Wait, so the code the attacker injects, it actually runs during a test?
Yep. And here's the real kicker. This admission controller, it often runs with super high privileges. I mean, it has to do its job. But that means the code that gets executed, it can access everything in the cluster, every secret.
That's how they get full control, right?
Yeah.
Complete cluster takeover.
Exactly. That's the nightmare scenario.
Earlier, you mentioned 4 specific CVEs, the ones Wiz Research found. Can you walk us through those? What exactly are we talking about here?
Sure. The first one is CVE 2025-24514. This is an injection through the auth-url annotation.
Okay.
The problem was that there wasn't any good input sanitization. So, you might use this annotation to specify an external URL for authentication, but an attacker could sneak in extra NGINX directives right inside that URL. Right. Like they could put something in there like http.example.com #injection point, and older versions, they just swallow that whole thing, include it in the NGINX config, and then bam, the injection point would get processed when they ran the test. So basically, the attackers could just tack on their own commands to the end. It's worth pointing out, though, that version 1.1.0, it did add some regex validation, which was a good step.
Regex validation, so like pattern matching to catch bad stuff.
Exactly.
Okay, so that one's CVE 2025-24514. What about the second one?
Right. So the next one is CVE 2025-0097, which works by injecting through the auth-tls-match-cn annotation. Now, this annotation, it's used to check if the common name in a client certificate matches, for authentication. It's supposed to start with CN, and then the rest has got to be a valid regular expression.
Sounds kind of secure, actually. Like, it's got some checks built in.
You'd think so, right? But Wiz Research, they're clever. They found a way, even with that CN and the regex requirement, they figured out how to craft a malicious string, something like cb/#anshtagjun. Wow.
Yeah. And this, it could still inject stuff into the NGINX config.
Right.
But here's the thing. To use this annotation in the first place, you also need the auth-tls secret annotation.
Oh, okay.
And that one points to a TLS secret in your cluster, either a certificate or a key pair.
So you need a valid secret just to get to the point where you can exploit this.
Yeah, it's kind of wild when you think about it. It's a good reminder, though. Even harmless-looking features, even in software that everyone uses, they can be dangerous in the wrong hands.
Right.
If you combine them in just the right way, security's complicated, man. You got to dig deep. Think about the paths attackers might take.
And since the Ingress NGINX Controller can see all secrets, the attacker.
They've got options, right?
Okay.
They could use any valid TLS secret, even one from a totally different namespace. Wiz Research, they even gave a list of some common secrets that are usually there by default. Things like Cube System Connectivity certs or Cube System as Load Balancer webhook tiles, stuff you might not even think about. It's like leaving the keys to the castle lying around.
Kind of, yeah.
Okay, what about the third CVE?
All right, so that one's CVE 2025-1098, and it's all about the mirror UID. The mirror annotation, it lets you make a copy of incoming traffic and send it to another service, for testing or monitoring.
Gotcha.
But the vulnerability here, it's that the in.uid field, this part of the Kubernetes object, wasn't being sanitized. And this field, it's not controlled by the annotation regex rules. So attackers could just inject whatever NGINX config they wanted straight through this field.
Oh, so it just slips right past the check.
Yeah, because it's not even checked. It's a more direct way in, right?
Hey.
Bypasses everything else.
Right. Okay, so that's 3. We've got one more CVE, right?
Right. CVE 2025-1974. And this one's the heart of it all. This is the actual remote code execution vulnerability.
Okay, so the first 3, those were all about getting the malicious code in there. And this one is how that code actually gets to run.
Exactly. Remember how the Ingress NGINX admission controller, it uses nginx-t to test the config? Well, Wiz Research, they figured out how to use the slengin directive. It's part of the OpenSSL module that NGINX is compiled with.
Okay.
And this directive, it can be used to load shared libraries at any point in the configuration.
Load shared libraries. So they can basically run any code they want, right?
Pretty much. Now, there's another directive, load module, which also can load libraries. But it can only be used right at the very beginning of the NGINX config, so it's really hard to inject. But slengin, it's got no such restrictions.
Ah, okay.
So they just inject a config that uses slengin to load up their bad library.
So sneaky.
Yeah, it's amazing, isn't it, how these seemingly innocent little features, they can turn into weapons. It shows you just how deep you got to go with security, right? Think about all the weird combos, the unexpected path.
Absolutely. Okay, so they can inject the command, but how do they even get that shared library file onto the pod in the first place?
All right, this is where it gets really clever. And honestly, a little convoluted. Wiz Research found a way to exploit NGINX's client body buffering. Basically, if you send an HTTP request and the body's bigger than 8 KB, NGINX might save that to a temporary file
Right.
on the pod's file system. So the attacker, they send a big ol' request, and the content. That's their malicious library.
Snooky.
The catch is NGINX usually deletes this temp file right away.
Okay.
But it keeps a file descriptor open to it for a little bit longer. So what the attacker does is they set the content length header to something way bigger than the actual content.
So NGINX thinks there's more data coming.
Exactly. It just sits there waiting. And that keeps the file descriptor open. It's a combination of like file system tricks and just kind of guessing how things work.
That's wild.
Yeah. It really shows you how persistent attackers can be, right? Finding ways around what seems like a temporary fix.
So they've got the file descriptor open, but the file's gone, right? How do they actually use that to load the library?
Yeah, they can't just use the regular path anymore. Instead, they have to use the proc file system. It's a special thing that gives you info about running processes.
Oh, interesting.
So they got to guess the process ID, the PID of the NGINX worker, and the file descriptor number, the FD, for their uploaded file.
That sounds tough.
It can be. But in a small container environment, there's not a ton of processes running, so it's doable. You just got to make some educated guesses. It's like the file's gone, but the system kind of remembers it was there, like a ghost, and the attacker can still point to that ghost.
That's a great analogy. Okay, so let's put it all together. The full exploit chain that Wiz Research figured out,
Right.
they upload the bad library using that body buffering trick, right?
Right.
Then they send an admission review request with one of those injected directives, maybe the Slungen one, and they point it to the procpi fdfdfd ember of their library.
Right.
And then when NGINX tries to test the config, boom, it loads the library and the attacker's code gets to run.
Exactly. It's a multi-stage attack. Takes advantage of all these subtle little behaviors in NGINX and Kubernetes.
So this is seriously bad news. What kind of damage can they actually do, and which versions are affected?
Well, like we said, worst case scenario is they completely take over your Kubernetes cluster. If they get RCE on the Ingress NGINX Controller pod, that's basically game over. They can get to all your cluster secrets.
Yikes.
Based on Datadog's analysis of Wiz's research, the versions that are vulnerable are anything earlier than v1.1.0, everything from v1.11.0 to v1.11.4, including those, and v1.1.1.0.
So if you're running any of those versions, you're in trouble.
You're potentially vulnerable, yeah.
All right, so what can people do about it? How can they check if they're affected, and how can they fix this?
Well, first thing is figure out if you're even using the NGINX Ingress controller. There's a command for that.
Yeah.
get pods, all namespaces, selector app.kubernetes.io name, Ingress-NGINX. It'll show you all the NGINX Ingress controller pods running in your cluster.
Okay, and if you find some?
Next, check if the admission webhook config is there. You can use kubectl, get validating webhook configuration Ingress NGINX admission. If it exists, that's another sign you might have a problem.
Got it.
It's also super important to check if the Ingress NGINX controller admission service, if that's publicly accessible.
Okay.
It shouldn't be by default, but you never know, right?
Okay.
Misconfigurations happen. To check, you can use kubectl get service Ingress NGINX controller admission Ingress NGINX. Look at the type and external IP fields. If the type is load balancer and it's got an external IP, well, it might be exposed.
Right, so check for the controller, check for the webhook, check for public exposure. What about fixing it? What's the most important thing people should do based on Wiz's research and the patches they made?
Upgrade. Upgrade to the patched versions as soon as you can.
I'm sensing a theme here.
Yeah, that's really the best advice right now. Based on what we know from Wiz and the Kubernetes and Ingress NGINX maintainers, you want v1.1.1 or later. That's Helm chart 4.1, 2.1, and up. Or for the older branch, v1.11.5 or later. That's Helm chart 4.11.5 and up. Those versions have the fixes for all the stuff Wiz found.
Upgrade, upgrade, upgrade. Got it. But let's say someone can't upgrade right away. Are there any temporary things they can do to reduce the risk?
Yeah, if you're stuck, there are a couple things you can try. Some of these were even suggested in the advisories that came out after Wiz's research. First, make sure you've got really strict network policies in place. You want to lock it down so only the Kubernetes API server can talk to the admission controller.
Okay, so limit who can even get to it in the first place.
Exactly. Reduce that attack surface. The second thing is you can temporarily disable the admission controller completely.
How do you do that?
If you used Helm to install Ingress NGINX, you can reinstall it, but this time use the option controller.admissionwebhooks.enabled false. If you did a manual install, it's a bit more involved. You'd need to delete the validating webhook configuration called Ingress NGINX admission, and then take out the validating webhook argument from the Ingress NGINX controller container. You do that in the deployment or daemon set.
Okay.
But, and this is super important, Remember to turn the admission controller back on after you upgrade. It does important stuff, helps keep your Ingress configs safe.
So these temporary fixes, they reduce the risk, but they also turn off some security features. Upgrading is still the way to go.
Exactly. That's the main takeaway from all of this.
Are there any tools or scripts that can help people detect if they're vulnerable?
Yeah, actually. Wiz Research, they mentioned a nuclei template that can check for exposed Ingress NGINX admission controllers. And Datadog, they put out a Python script that can help find vulnerable clusters. That was based on what Wiz found, of course. For more in-depth stuff, you can check the logs for your NGINX pods, look for validation events, and see if those match up with any API server events. Keep an eye out for specific messages, things like bind engine error. Datadog highlighted that one as a possible sign of someone trying to exploit this, and it makes sense based on what we know from Wiz's research. You should also check the activity of the Kubernetes service account called system.serviceaccount.ingress-nginx-nginx-admission. Look for anything weird, like strange API activity, odd user agents, or requests coming from external IPs. And if you're a Wiz customer, they've got pre-built queries and their dynamic scanner, which can help with detection too.
It sounds like there's a lot people can do, both for detecting and mitigating these vulnerabilities, thanks to Wiz Research and the whole community.
Yeah.
It's all about being proactive, right?
Absolutely.
Before we wrap up, can you tell us a little about how this vulnerability was even found, how it was disclosed?
Yeah, sure. So Wiz Research, they were already interested in Kubernetes admission controllers as a potential attack surface. They figured these things, they often run with high privileges, and they're reachable over the network without any authentication. Sounds risky, right?
Yeah, it does.
So they did a deep dive into the code for the Ingress NGINX admission controller. They were really systematic about it. They found all those different ways to inject code through the annotations and the UID field. And finally, they discovered that trick with the Selenium directive, how it could be used for remote code execution.
Amazing work.
Yeah, they did a great job. And they were very responsible about it, too. They reported everything to Kubernetes back in late December 2024. They worked with the Kubernetes and Ingress NGINX maintainers to make sure they were fixes ready before they went public with it on March 24th, 2025.
So everyone had time to patch things up before the bad guys even knew about it.
Exactly. That's responsible disclosure.
That's awesome.
Yeah.
So thorough research from Wiz Research and a responsible approach to letting the community know. This IngressNightmare thing, it's not something to take lightly, folks.
Nope.
Especially if you're using Ingress NGINX.
Absolutely. The risk of a full-on cluster takeover, it's just too big to ignore. Check your versions, upgrade as soon as you can, and if you can't upgrade right this second, put those mitigations in place. Use the guidance we talked about, the stuff that came out after Wiz's findings.
Solid advice. And that brings us to the end of our deep dive for today.
Yep.
If you found this information helpful and you want to support us in making more deep dives like this, please consider liking and subscribing. It really helps us out.
And one more thing. Please remember that this content is created by AI. So think of it as a news source, a way to stay informed. It's not security advice, okay?
Right.
If you need specific guidance, talk to a real live security expert, someone who knows your environment.
Absolutely. Thanks for joining us on this deep dive into this very important security issue.
Thanks for listening.
Okay, one last thought before we go. This whole situation, this IngressNightmare that Wiz Research uncovered, it really makes you think, doesn't it? We've got these endpoints that are open to the network, no authentication, often running with high privileges, sitting inside what we think of as our secure internal cloud. It's a reminder that the principle of least privilege, it's crucial, even for things that are just doing validation, like this admission controller. So the question is, what other hidden attack surfaces are out there, lurking in the shadows of our cloud-native world? Something to think about.